In this video, I'm going to introduce a couple of other keywords that can be useful when you're filtering with where. The first keyword is between, which you can use to check whether a value is in a specified range. So for example, if we're working with the customer table, and if we wanted to only return those customers where the ID is between 1 and 5, we could use the between keyword. Running that. So rather than using greater than or equal to and less than or equal to, we can use between. It's a much simpler, more condensed way to write the same thing. And we can also do not between. So if we only want to see the customers with an ID that's not between 1 and 5, we can just put not at the front, like so. The other convenient keyword that I want to introduce is in. And you can use in to check whether an expression is equal to at least one of the elements in a set. I'll demonstrate this by only returning customers where the customer ID is either 1, 5, or 8. Running that. And we can also use not here as well for the same effect. And so you can see here in the result set, we've returned all the customer IDs except 1, 5, and 8, which are missing. You can also use these keywords to filter expressions as well. If we wanted to write a query which only returned the first names that don't begin with A, F, or J, we could do this as follows. And we'll use this left function that we learned about earlier. And we'll run that. And so what we've got in our output now is only those customer names that begin with A, F, or J. And we've used this left function, as we have in previous exercises as well, to just obtain the first character in a customer's first name. And so in and between are just nice convenience keywords that save us having to chain together lots of logical and or conditions. A third keyword I want to introduce in this video is the like keyword. And we can use the like keyword to search for patterns inside strings. This is a big complex topic, and Postgres actually has full support as well for rich text regular expression matching. For now though, let's just look at the like keyword, and let's look at two common wildcards and their usage. The first wildcard is the % symbol. So what I'm going to do is write a query that returns all the customers where their first name starts with M. And I'll use the new like keyword. Running that, and you can see in the output, I've returned all the customers that have a first name that starts with M. So what I've actually done here is specify a pattern which is matched against the customer first names. And what I'm saying is that the first name has to match the pattern of starting with the letter M, and then I use the % symbol after that. And the % symbol will match any string of characters, including an empty string. When you're using the like keyword, you can also match just a single character. Let's say then that we wanted to write a query where we wanted to return all the first names where the third character in the name is an M. We would do that like this. __M. And you can see that I got 5 results there. So these are all the customers with a first name that has an M as the third character. I'm actually missing one more thing though. What I should really have here is a % symbol. And now what I will match finally is customers that have any character appearing as the first 2 characters of their first name. The third character must be an M, and then anything after that is permissible. So let me run that now with this fix. And you can see now I've actually got the output that I wanted. So I match now on customers with the first name like Emma. The like keyword is part of standard ANSI SQL. There's a variation of this which is just specific to Postgres, and that's I like. And what I like will do is it will perform that same type of matching, except it will be case insensitive. So in this case, whether you're matching uppercase M or lowercase m, the results will be the same. So let me change that to a lowercase m now, and you should get the same results. There are some other wildcards that are supported as well, in addition to underscore and the % symbol. And there are actually some other keywords as well, like similar to, and even full regular expression support. In my opinion though, it's the kind of thing that you should just look up and learn about when you need it. And I've included a link in this video description where you can learn more about string and pattern matching. Just to give you a quick glimpse though, there's another keyword called similar to, which again is part of the ANSI standard, which does actually have pretty good regular expression support. I'm not going to go into detail and explain this a lot, but just to give you a bit of a fun example of the kind of powerful things you can do with similar to and full regex support, what I'm going to do now is show you a query where I'm returning all the customers with a first name that starts with M and contain 2 repeated letter L's somewhere in their name. So I'll do first name, similar to, starting with the letter M, and anything can come after that M. It needs to have 2 L's repeated, and then anything can come after that. So let me run that. So there are 3 customers with a first name that start with the letter M, and for each of those customers, somewhere in their name, they have 2 repeated L's. So that's just an example of the kinds of fun types of string and pattern matching that you can do with similar to. If you're interested in learning more about different ways that you can match text and all the types of regular expressions you can do with SQL, click the link in the video description and check that out. And as always, make sure you have a good go at the exercises. I think there's some really interesting exercises that accompany this particular video.